Hi everyone, this is EL6303 homework 5. In this video I'm going to show you the first problem of this homework. In the first question, we need to compute the density function of Z by convolution method. This is a original figure of a density function x, and this is the figure of a density function of y, and for the lowercase f, which is a density function of x, is a unit function at 1 minus unit function x at 2, and we can shift the figure left. Left shift 1, and we get exactly the same figure with the density function y. So we know that the relationship between z and xy is z equals to x plus y. So we have the density function relationship is fz equals to f, the convolution of fx and fy. So according to the definition of a convolution, we have the integral of this function with respect to alpha, and we put these two function into this one, so we get a longer function. So we can use this one and tear it apart. So we have we have this four part of a function, and this one is from 0 to z, and this one is from 0 to z minus 1, and this one's from z to 1 to z, and this one 1 to from 1 to z minus 1. And so we have we know that the function is the function is 1. I mean, the x and y is 1. It in the interval of 0 in from 0 to 1. So so we have the result of the integral, which is z times unit function z minus z minus 2 times z minus 1 times unit function z at 1, and plus z minus 2 times unit function z at 2. So we need to shift it back to which we need to shift to right, and the z need to minus 1. So we put in the net in the equation below is z minus 1, and the unit function z at 1, and minus 2 times z minus 2 times unit function z minus 2 plus z minus 3 and times unit function z at 3. So the second question is to get the density function by geometric method. So we have the relationship z equals x plus y, and we know that the density function of x and y is 1 between 0 and 1, between 0 and 1. So so for this figure, this square is where it should is where z should have some value except for 1, except for 0. So we have three possible we have a three possible interval z from z from 0 to 1. This the density function, the distribution function of a z is the area of this little triangle. So the result is z squared over 2, and we do the derivative. We have the density function, which is z, and when z is between 1 to 2, so it's this line out here. So it's the distribution function is the big area of the area of a big triangle minus 2 little triangle of the area of a little triangle. And we have so we have final result is the first area of a triangle minus 2 times z minus 1 square over 2. And of course we need to do the derivative, and we have 2 minus z. This is a density function, and when z is more than 2, so which corresponding to this line out here, so the area, the distribution function is exactly the area of the square. So we have distribution function is 1 and the density function is 0, and for all these three results we can draw a figure out here, and of course we need to shift it back, which is right shift 1, and we have this figure, and we write down the density function by using unit function. So we have this result, which is exactly the same with the result we get in the first question.